Good morning to all. In surface chemistry chapter, we have discussed already in the previous video so many topic. So today I am going to discuss the last topic of according to this year's syllabus. The last topic, that is the protection of colloidal solution. As we have already discussed about the coagulation and the different types of methods of coagulation, like addition of electrolyte, we can coagulate the salts by electrophoresis, by persistence dialysis, by mixing of positively charged salts, and by boiling also, by boiling. And apart from this, we have discussed about the Hardy-Schulze rule, Hardy-Schulze rule, and coagulating value. These all are very important regarding this particular chapter. So let's we discuss about the protection of salts. For example, how can we protect the lyophobic salts? So let's we discuss about the lyophobic salt. So write down the headlines of particular chapter topic: protection of lyophobic colloids by lyophilic salts. Protection of lyophobic colloids or salts by lyophilic salts. As we know that lyophilic salts are stable due to extensive solvation. So how can we protect lyophobic salt by adding lyophilic salt? Suppose we have two lyophilic. Suppose this is the lyophobic salts and this lyophobic salts. If we add a small amount of electrolyte to it, the electrolyte which is lyophilic in nature, small amount of lyophilic electrolyte added to it means lyophobic salts. So lyophilic salts cover the lyophobic salts. That's why these two particular lyophobic salts do not add together and they can be stable. Suppose in our electrolyte there is a potassium present. So this potassium does not neutralize the lyophobic salts, and in this way these particles means by adding lyophilic salts in a small amount, it makes a protective layer around the lyophobic salts, and lyophilic salts particles becomes stable. So write down the points. This is also an important point, why lyophobic salts become, or high lyophobic salts becomes stable by adding lyophilic. So write down the points. Lyophilic salts have unique ability to protect lyophobic salts from coagulation. And the next is the lyophilic salts. Lyophilic salts forms a protective layer, forms a protective layer over the particles of over the particles of lyophobic soils and protect them from coagulation and protect them from coagulation. In this way, we can easily protect the lyophobic soils by adding small amount of lyophilic soils, because lyophilic soils are stable due to extensive solvation. To understand the protection of power of lyophilic soils, let's explain or define an important term which is called the gold number. Which is called the gold number. What is gold number? Gold number. It can be defined. It can be defined as the mass of lyophilic colloids in milligram, which can protect 10 ml of a gold soil from coagulation. On adding 1 ml of 10% NaCl solution is called its gold number, or we can say that protection power is inversely proportional to the gold number. Suppose we have a solution of gold. This is the gold solution. And when we add lyophilic colloids, so in lyophilic colloids in milligram, and when we add 1 ml of 10% NaCl. So in this way we can find out the gold number of particular solution. Means how can we define what is the gold number of this particular, so in this way we can define the gold number of gold sold from coagulation when we add 1 ml of 10% of NaCl. So write down the definitions. Minimum milligrams of the protected colloids, minimum milligrams of protected colloids required to prevent the coagulation of colloid, required to prevent the prevent the coagulation of 10 ml standard gold sole, 10 ml standard gold sole by 1 ml of 10% NaCl. 10% NaCl. Solution. NaCl solution is called gold number. It's called gold number. When gold sole coagulate, the colloidal changes from red to blue. Smaller the gold number, greater is the protecting power of lyophilic core. So when the gold sole coagulates, its color changes from red to blue. Smaller the gold number, greater is the protecting power. Smaller the gold number, greater the protecting power of the lyophilic colloids. So when the gold sole coagulates, its color changes from red to blue. Smaller the gold number, greater the protecting power of the lyophilic colloids. So let's see a few examples of gold number of following colloids. Gold number of protective colloids. So let's lyophilic colloid, then gold number. This is a simply example, and lyophilic colloids and gold number. So suppose we have hemoglobin. Lyophilic colloids is hemoglobin. So the range of gold number is 0.03. Suppose gelatin. Next example is gelatin. Gelatin is also a lyophilic colloids, and their range is 0.005 to 0.01. And suppose egg albumin, it is also a lyophilic colloids, and their gold number is 0.15 to 0.25. This is not so important, but for the knowledge point of view, you can learn is among the above lyophilic colloid, gelatin is the base protective colloids. Among this, the gelatin is the base protective colloids, because lower the gold number, greater the protective colloids. So in this way you can simply find out the gold number of following colloids. So the next topic is application of colloid. So students, applications you can go through the NCERT. With this particular topic, we have completed our surface chemistry chapter according to this year syllabus.